This voiceover was added after the pre-recorded video as a run-through guide. So we just logged into the MPC cluster through SSH. And now we're checking for the available nodes on the cluster using the my host file, which contains the name of the nodes in the cluster. So for this demo video, we're going to be using 5 processors and 9 processors. So now we're changing the DEM size from 500 to 50 for faster image rendering for this video. So just compile the code, and now this is the command to run it. So that's the number of processors for this run is 5, and then that's the host file used, and then that's this is the path to the DEM input file, and the last 2 floating point numbers are the coordinates. So running code. On top you will see the communication that happened between the nodes printed out, and then below that you will see the first 10 computed catchment areas represented as Google Maps coordinate links. So we are currently waiting for the 3D okay, so that's the 3D rendered image. So the current rainfall is set to 1 on all cells, which explains the heavy rainfall on the image represented by the yellow areas. So the yellow dots are actually the rainfall points and the flow, rainfall flow. So now we're going to demonstrate the same code with the same input file using 9 processors. So again, on top you will see the communication that happened from the slave node to the master node. And again, we're waiting for the 3D image launcher. This video is actually fast forwarded. So that's the same image, but that image was now computed using 9 processors. So we are currently logged out of the cluster, and we are fetching a pre-recorded video of the same code running this time on 1000 by 1000 DEM data input size. So that's the 3D image launcher. You see the yellow points as the rainfall flow. And we're zooming in. For a better view of the rainfall flow. So now, I'm going to open the terminal and do another demo. So we are changing the rainfall probability to random. So the rainfall probability, if you remember, is set currently to 1, and we're changing it to rain amount, which can either have a value of 0 or 1. And this time, we're going to change the data size to 500. Which means 500 will be multiplied by 2, which would mean that the dimensions of the DEM data to be used in this run is 1000 by 1000. 1000 by 1000. So we're running the code, and what's going to happen is I've encountered an error. Later you'll see the error sign right there. And for the next few minutes, I'm going to debug it, only to find out later that I entered the wrong coordinates. So while the debugging is happening, let me remind you that we are logged out of the cluster, and we are currently using proxy processors created by MPI automatically in my laptop as I run the code. So we're not in the cluster, and we're just using the proxy processors in my laptop. And also earlier, while on the cluster, we used smaller dimensions as the input size because it takes a long time for the rendered 3D image launcher to appear on my laptop screen because it's highly dependent on the speed of the internet connection. So to save time, I just made a pre-recorded video of a large data input, and now I'm going to show you a demo of a large data input, but not in the cluster to save time, but as just in my laptop for using a larger data set. Again, what happened was we changed the rainfall probability from 1 to random. So we're going to run this using a larger data set, again 1000 by 1000. So the bug was fixed, and this is a demonstration of how it would look like if we could run the code with the random rainfall points as opposed to the previous images in which all the elevation cell was given a rainfall amount of 1. So the image looks a bit messier because again the rainfall points here that's being used is random. So we're zooming in to get a better view of the rainfall points represented by the yellow dots. And so I'm just going to show you again the part of the code that specifies the rainfall amount, which we changed from having a value of 1 for each cell to having a value of either 0 or 1 depending on the pre-computed rainfall. So that's it. Thank you for watching.